Hello guys, I am Ali Jawad and welcome to my YouTube channel. In this video, we are going to do lesson number 2 on chapter 26, Radioactivity of syllabus physics 5054 for Cambridge and O-level students. So let us start with our lesson. In the first lesson of radioactivity, we have discussed that how the atom becomes unstable and why it releases some particles and rays to become stable again. We have also seen the definition of radioactivity and the type of rays or particles emitted during radioactivity and the experiment conducted by Rutherford. In this video, we will try to cover the radioactive decay equations, that how to represent radioactivity in the form of nuclear equations. So this is the nucleoid notation. X represent any element which is performing radioactivity, while Z represents its atomic number, while A represents the nucleon number or atomic mass. So this notation is used to represent the radioactive decay reactions. Now, as we have learned that during radioactivity, the three types of particles are emitted or rays are emitted, which are named as alpha, beta and gamma respectively. So it is not necessary that all the particles and rays are emitted from the single atom at the same time. It can also be possible that only alpha particles are being emitted or only gamma rays are being emitted from the element respectively. So if the atoms is emitting alpha particles, that means it is undergoing alpha decay. If it is emitting beta particles, then it means it is undergoing beta decay. And if it is emitting gamma particles, then it means it is undergoing gamma decay. So let us see how to write the equations for alpha, beta and gamma decays respectively. In alpha decay, a particle equivalent to helium atom is ejected out of the nucleus, and the unstable parent nucleus converts itself into a stable daughter nucleus. Now, if we may try to write an equation on an isotope of uranium for alpha decay, so we can write it like this. The 92 represents the number of protons, while 235 represents the nucleon number, atomic mass. So if the alpha particle is being emitted, then obviously +2 charge has been ejected out of the atom, while 4 nucleus particles or nucleons are emitted out of the atom. So what we are left with? Yes, we are left with 90 positive particles in the nucleus, while 231 nucleons. So the uranium has converted into its daughter element by emitting this alpha particle, and this process is known as alpha decay. Similarly, for beta decay, if the element is undergoing beta decay, so a particle which is equal to that of electron is ejected out of the nucleus. Let us see how to write its equation. So for example, radium, it has 88 protons in it and 228 is its atomic mass. So when a beta particle is emitted, it means a negative charge is getting out of the nucleus. But by the way, from where this negative charge has come into the nucleus? Because from our knowledge of chemistry, we know that only proton and neutrons are present. So a neutron get splitted into a positive particle, means proton, and a negative particle, that is electron. So collectively they make up a neutron. So positive particles are stable in the nucleus while negative are not. So the neutron has converted into an electron and proton, and this electron has ejected out of the nucleus. And therefore, an extra proton is produced or will increase after the beta decay. So if negative particle is being emitted, so this is because a neutron has converted into a proton and electron, and this electron is getting ejected out of the nucleus like this. So what we are left with, an extra proton, and that is why after beta decay the atomic number of the element increases. So radium has become now actinum while the mass number remains same. And why it is so? Because the neutron has only getting converted into proton and it is not leaving the nucleus. So in place of neutron we have got an extra proton, and that is why the nucleus number or the nucleon numbers remain unaffected. In gamma decay, since we know that gamma is a type of ray, it does not has any charge and mass on it. So it means that an excited nucleus which has high amount of energy is trying to relax by releasing the energy from it in the form of gamma rays, which is a part of electromagnetic spectrum. And upon releasing the energy, it is coming to a relaxed state. And in gamma decay, that is why you can note that no change in mass and charge number is there, because it is only a release of energy. So these are the radioactive decays and the method to write the equation for it. I hope that you have liked the lesson. Don't forget to subscribe our channel to watch the latest videos on the same topic. Thank you for watching.